So consider the region bounded by the curves y equals root x, y equals 2, x equals 0. So that's this region right here. So you got to be careful which region you're going to revolve or rotate around a line, because it could be you're looking at a couple different regions, right? We want to rotate around x equals 4 using the washer method. So there's your line x equals 4, and we want to rotate this way. So you got to be careful not to choose this other region, right? And the key would be the y equals 2, I think, that if that's part of the bound, then it has to be this upper region. Okay, good. So once we have that figured out and we're using the washer method or the disk method twice, really, what I want to do is first, if I'm revolving around a horizontal line, I just got to remember that I need my functions as functions of y. Okay, so that is input y, output x. So if we want, we can solve this for x. And my bounds, of course, have to go from here to here if we're doing a function of y, right? That's over the y region. Okay, so using the formula, then we need a big R and a little r, right? So basically, the volume is going to be represented by big R squared. That's the distance from the line of rotation back to like the outer region. So I'll use green for that. That's big R of y. And I have to square it. And then little r, right, the inner region or the whole of your washer is going to be represented by the distance from here to here, right? That's your little radius as you rotate that thing around. Of course, that depends on where you are on the curve, right? But I'm just drawing like one instance of that. So that's going to be little r as a function of y, okay? So when I go to do my formula, then I'm going to have the outer radius squared minus the inner, and that'll give me my volume, okay? So all that's left is to figure out a representation for the inner and the outer, right? So the distance, the green distance, right, this is constant over this whole interval or this whole region. Then the big R is constant. It's just 4, right? The distance from this line back anywhere is constant at 4. And the little r would be this what I'm using a blue line for, the distance from here to here, which will depend on y. Right? It's going to depend on y. It's going to be this line, distance from here to here is 4, minus the distance from here to here, right? Which is given by the curve, which is right here, y squared. Okay, and that's it. That's the setup for the volume. We could do a little bit better than that. That's of course 16. I am missing my squared right here, so I could FOIL that out. 4 minus y squared would be 16 minus 2y squared plus y to the 4. Then we could write that as one nice polynomial to integrate. But I'm just asking you to set, and we could do the integration to find the volume. But right now, just kind of working on the setup. So this would be okay. You could simplify that a bit, but either case would be fine. Next one, same region. We're going to use the shell method. All right, so I like to draw one section right here, one part of the shell that when I rotate it around this line, it helps me, try that again, rotate it around this line, it helps me visualize what goes on here, because again, I need distances. The shell method works a little different. We're going to find this distance. We call that h of x, I think. Your book called it that. And then we need to find the distance from this thing to here. P of x or r of x, doesn't matter what you call them, you just need functions of x there. And again, it's always important to remember if you're doing the shell method and you're rotating vertical, then you're dealing with functions of x. So let's use our formula for shell method then. It's going to be the volume, same volume now, same region. Make sure we're choosing this region. Volume equals 2 pi x bound 0 to 4, distance to line of revolution, height, dx. Okay, so again, the picture really helps, right? That allows me to visualize the height and the distance to the vertical line x equals 4 as functions of x. Okay, so if you just let's focus on what I'm calling p of x, the distance from here to one of these rectangles would be 4 minus the distance from here to here. Right? Does that make sense? If we're rotating around the y-axis, then the distance from here to here is x. Right? We can represent that by a function of x, just the value x. That's how far it is from here to here. But if I'm rotating around x equals 4, the distance from here to here, I have to do the thing where I subtract. Right? It would be this distance, which is 4, minus this distance, which is x. Okay? So that's going to be what I'm calling p of x. And now I need the height of this guy. And it's sort of the same thing, sort of the same idea. Basically what I'm going to do, let's use green. To find this distance is start with this distance and take away, start with the green distance and take away the pink distance. Right? That would leave me with this distance. That's what I have to do when it's not touching the x-axis. If it was the other region, it would just be square root of x. Right? If it were this region here, then the pink distance is root x. And that's a little bit easier, the height from the x-axis to the curve. But because it's a hanging distance, really, then I need to figure out an expression that represents that distance. So it would be the whole distance, which is, I'm sorry, I said 4, I meant 2. That's y value 2. This distance minus this pink distance. All right, which would be 2, the whole distance, minus your function value root x. 2 minus root x. Okay, and that represents your volume. All right, so what let's use pink. That volume is equivalent to that. They should be the same thing. Right, and this, of course, we got by the washer method or disk method, and this is the shell method, if I didn't say that already. Okay, and I'm going to skip it. It'll take a while to get there, but I believe ... Yeah, you got some work to do here. This isn't a terribly difficult integral. We're going to FOIL this, and we'll have an x to the 1/2 expression, an x to the 3/2 expression. And a constant expression. And then, of course, an x expression. You have 4 terms when you FOIL that out. Simple power rule. A lot of work. And then you should end up with, I believe, this solution. See if you can get that.